welcome to my channel. In this video we are going to learn about the selection sort in the sorting techniques of data structure. So selection sort, it is going to sort an array by repeatedly finding minimum element from the unsorted part. So here we are going to select the minimum element from the unsorted array, and we are going to compare it with the first element in the array. Okay, so we are going to selection sort means we are going to select a particular element from the given unsorted array and we are going to compare with the first element of the array, and if it is greater then we are going to swap these two elements, right? So we are having the two subarrays here, that is a sorted and unsorted list. So we will see about the selection sort with the example. So we are considering the array of elements here. So number of elements here are 7. Okay. So first we are going to consider the starting of the element. So in the selection sort we are going to select the minimum element from the given array. So what is the minimum element from the given array? So this total array is an unsorted list of elements, right? So we are going to select one minimum element from the array, so that is 1. Okay, and consider the first element of the array. So we are going to compare the minimum element in the array with the first one. Okay, so here 9 is greater than 1, so we are going to swap these two elements and make the 1 as the new minimum element. Okay, so we are going to compare these two elements. So 9 is greater than 1, so we are going to swap these two elements. So 1, 3, 9, 4, 2, 7, 5, right? So now, so 1 is sorted here. So this is a unsorted array. 3 to 5 this is a unsorted array. So now we are going to, so we are not going to consider 1 here. So starting from 3 we are going to consider the unsorted array. Okay. So now we are going to search for the minimum element here, that is 2, and starting of the array element, that is 3. Okay, so we are going to compare these two elements, right? So 3 is greater than 2, so we are going to swap these two elements. So now 2 will become the new minimum element, and 9, 4, 3, 7, 5. Okay, so this is the unsorted array. So now in the unsorted array we are going to consider the minimum element, that is 3. So 3 is the minimum element here, and 9 is the starting of the array. Okay, so compare 9 with 3. So 9 is greater than 3, so we are going to swap these two elements. So now 1, 2, 3 is the sorted one, 4, 9, 7, 5 is unsorted one. So now again we have to compare these elements. Okay, so here the 4. So 4 is the starting of the unsorted array, and here 4 is the minimum element itself. Okay, so that's why it gets, so it is already sorted here. Okay, so now if you consider the next one. Okay, so in the 9, 7, 5, so what is the minimum element? That is 5, right? So 5 and starting of the element is 9, so 9 is compared with the 5. Okay, 9 is compared with 5. Okay, so it is greater than 5, so we are going to swap these two elements. So 5, 7 and 9. So in this manner we are going to swap all these elements. Okay, so first of all we have to select one minimum element from the given unsorted array and compare it with the starting of the array, starting element of the array. Okay, so this selection sort is a stable and in-place algorithm. Okay, so here we consider the best case. So here also we are going to perform the n-1 number of iteration in the first pass, n-2 iteration in second pass. Okay, that means we are going to compare the elements in the given array. So n-1 number of times in first pass, n-2 number of times in second pass. So that's why the time complexity of the selection sort is big O of n square. So in the best case, if the given array is already sorted, then the best case will be big O of n square. Okay. So in the case of the average case, if the existing element are in jumbled order, that is neither ascending or descending order, then average case arises, that is big O of n square. And worst case arises when we sort the descending order of an array into ascending order into the ascending order format, then the worst case occurs, that is the big O of n square. So selection sort. So why do we need the selection sort instead of bubble sort? Means selection sort enhances the bubble sort by making only a single swap for each pass through the run. Okay. So that is the advantage of the selection sort. So we are going to make only a single swap for each pass, but in the case of bubble sort, for each pass we are making the n minus 1 number of iterations here, right? But here instead of that we are going to make only single swap, right? So let us see the code of the selection sort. So here we are also considering the 0 to n minus 1 number of passes, right? 0 to n minus 1 number of passes. That means, so what is the number of elements in the given array? 7, right? So we are having the 6 number of passes. So here we are considering the n minus 1 number of passes because, so here if you see, we are going to perform the n minus 1 number of comparisons and swapping. So 1, 2, 3, 4 and 5. So here we are doing 2 times, right? For 4 and 5. Okay, 4 and 5 and 6. So we are doing 6 number of comparisons here. Okay, so that's why we are taking the 0 to 6. 0 to 6. So first of all we are considering the minimum equals to I. Okay, so we are considering the minimum equals to I. So in the given example we are considering the first element of the array as the minimum element. Okay, so first element of the array is 9. Okay, so which is the ith element, so we are considering it as the minimum element. Okay, and we are considering the 1, that is the minimum element, as a j. Okay, and we are comparing the j with the minimum element. Okay, so here I is the minimum element and j is the minimum element of the unsorted array, so 9. Okay, so we are comparing the j with the I. Okay, whether the j is less than I or not. So if the j is not less than I, so we are not going to swap or anything. So here the j is less than I, so that's why we are going to swap these 2 elements and make 1 as the new minimum element. So we are setting the 1 as the new minimum element. So swap minimum with the first unsorted position. Okay, swap the minimum with the first unsorted position in the array. So in this manner we are going to repeat this, right? So minimum equals to I, that is the first element of the array. So minimum here is the first element of the array. So j equals to I plus 1. So here we are going to divide the given array into 2 parts, that is the sorted and unsorted part. Okay, so we are considering the first element as the I as the first element, right? So minimum equals to I and j equals to I plus 1. So after the I value, that is starting from the index 1 to index 6. So we are considering the elements here. Okay, so j equals to I, that is the j equals to first index of the element. Okay, so starting from there we are going to consider the minimum element, right, that is j, and compare it with this starting element. So we are going to compare we are searching the minimum element in the array. Okay, and we are going to compare it with the first element of the array, that is the I. Okay, and then we are going to perform the swapping of these 2 elements, right? So this is the this code is for the swapping 2 elements. we are considering j and a of minimum, that is the first element. So here don't get confused, here a of minimum is the first element, okay, first element of the unsorted array, and j is the minimum element in the unsorted array. So j is the minimum element in the unsorted array and a of min is the first element in the unsorted array. So we are comparing these two things. So if j is less than a of min, that means the starting one is okay. So if the starting element is greater than, or the minimum element is less than the starting element of array, then minimum equals to j. Okay. So we are making the j as the new minimum element. So in this manner we are going to execute the selection sort. Okay. So this is about the selection sort algorithm, and thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.